Nope.
Good morning, everyone.
I mean, it's the closest Neuroccino to April's Fool, so.
Last week was
Last week?
yeah.
Oh, damn, yeah.
Yep. That was a missed opportunity.
Yes.
I mean, was it the last one, the one where we messed up with the connection?
Yes.
Oh, then there you go. It was not messed up. It was just April's Fool.
Right.
So people was telling me that on the website, on the Neuroccino website, the link is not the proper one for the Zoom.
Still, I
Again?
updated them all.
Yeah, you sure? Someone told me it's not. Oh, I didn't check.
Well, if you go on the main website, there's a button, join us.
Okay, so
That one works.
I mean, I
If there is
usually go
still,
to the website.
just going to switch off the Neuroccino website if that keeps happening.
Like from this page.
Hello. Hello.
yeah, I think it's yeah.
I thought we went through all of them and updated it, but maybe there's still a bug. But we have a lot of people in the room. Can't be that difficult to find the link.
Yeah.
But I'll check later.
Oh, Ruben.
Good morning.
Hello. Good morning.
Right, let's get started. Welcome to Neuroccino on Monday morning, 9:32 at this point because we're chatting. As every week, one volunteer presents a paper or something exciting they found and tells us about it, and then we discuss it to the best of our knowledge with the only rule that it can't be your own exciting work. And today we have Hervé again, who, as we know, always puts on a good show. So Hervé, take it away.
Okay, so I think, yeah, I share the link again for Marcella. And I'm gonna share my screen. Okay, can you see it? Yes. So yes, last week I was looking for an article to present, and I found one about social economic status and genetic influence, but I changed my mind. I found this one. So a friend of mine and a former colleague was advertising it, and I say, wow, interesting topic. So let's talk about failures in science. So that was, yeah, I wanted to talk about it. So this article was published in Neuro 2 weeks ago, I think. And it's a kind of ode to scientific failures. So what is about? So this paper is linked to the SFN conference, and what they say is when you go to a scientific conference like SFN, what you see is mostly famous keynote speakers, beautiful scientific results, and award ceremonies. So everything looks nice, everything is perfect. But is it the real scientific world? Maybe not. So it's why they wanted to discuss about what is real research. And so what they say is it's true that when we do research, we come with a lot of failures. So it can be failures on experiments. For example, you start something and it doesn't work. You start writing articles, you try to publish them, and it's a nightmare. So reviewers don't get it or they don't want it. So that can be difficult. When you want to do research, you submit grants, you want money, and it's a nightmare too. So they don't want to give you money because they don't trust you or they don't trust your research. Can be difficult. And even when you search for a position in academia, you can not have the position you want. So it's always matter of failures in a way. And one point they make is we rarely discuss it in public. We don't advertise, we make a lot of mistakes, and we do a lot of failures. So it's why they, and in the introduction, they talk about how science is made of mistakes. So there is a quote saying that infallibility just doesn't belong to science. So that means science, we do research by doing mistakes, but we don't advertise it. We don't say it. So that is something, it's tricky. So the ultimate goal of science is to be intelligently wrong. So we do mistakes to make progress. So we start research by saying people was doing that, but maybe it's not the proper answer. Maybe we should make it. Maybe it's the answer is something else. And here again, we don't advertise this. We don't disclose it. We don't disclose inconsistencies, mistakes, weaknesses in our research. And that maybe is due, it's part of the system. So the system in fundings, publication, and even if in career advancement, we don't get things saying that we do a lot of mistakes. So if you want a position, you will never saying that, yeah, I'm a great researcher because I made a lot of mistakes. So it doesn't work like that. So maybe it's a pity, but it's a way it is done. I think something was striking me in this paper is also the so first of all, it's also before that, I think it's opening discussion about mistakes can be interesting for awareness, to be aware that research is made of this kind of failures. Also, it can be a good training exercise for new people coming to the research, for example, students. So it can be part of the training. And so, yes, what I was saying that something I was striking with is for the public opinion and for the misperception of research, and for if we talk about fake news, misinformation. So one side is that, yeah, it's true, misinformation, fake news can be due to the fact we don't advertise enough research, we don't talk enough about research. But something I was thinking is maybe also we need to be careful how we talk about it. So when we present research like a real nice world where everybody is doing research like they don't do mistakes, public opinion can say, "Oh, look at these scientists. They do research and it's like that. So they discover something. And it's just appearing like that. They don't do mistakes. How is that so? How is that possible?" And so that can be a problem also for misinformation. And I think that was one, if I want to remember something about this paper, it's that. So yes, so they talk about it because they try to change this perception, this misperception in the SFN conference by doing activities, games to advertise failures. And so the way they want, the goal of this paper and these activities were to show the importance of failure, also to encourage scientists to openly discuss failures, and also to provide a forum for learning from each other mistakes. That was the three goals of this paper. And so they started that in 2021 during the SFN conference, and they proposed different activities to show how failures is important. The first one is just a storytelling session. It's an oral presentation where you ask a great scientist to come and to present what is what their greatest failures. So they do a oral session saying what they screwed up completely. Yeah, they did that from 2021. So for each activity, they present the context, the inspiration of it, the vision, the logistics. So they provide some advices for the storytellers, what to do, what not to do. So I will go deeper in, not deeper in it, but you can look at it and in the paper. They have also a YouTube channel where you can find all the speakers presenting their greatest failures. Okay. So the second game is the calculate your F index, your failure index. So this is the questionnaire where you have questions about different failures you can have, and the more failure you have, the more mistakes you have done, the more points you gain. So the people with that do the more mistakes will will win the game. So they provide again the same parameters. They provide some of the questions. For example, are the paper rejected? But I have a tweet for the end of this session, so I will not talk about it. So they provide different questions. Again, okay, impact. So they have a bingo game where. So the idea at the beginning was to talk about failure, but also to provide a forum, as I said, to discuss about failure. So the first one, oral session or speaker, is you can ask questions, but you don't interact with each other. So the game they tried to develop was where to make people discuss with each other about their mistakes and to present research, not as a ideal world, but as a real world with a lot of mistakes. And so so the bingo game is you are a team of people. Let's see, and you have these cards, and the best, if you are with people that do a lot of mistakes, you will be more probably winning because you need to find lines or column with all these mistakes or failures that happen during research, which can be broke a piece of equipment, a stolen laptop, and stuff like that. They provide some of these bingo game cards. And the last game is where is it? It's somewhere. Yeah, it's for confessional. So here it's really it's a group based activity where you are, for example, 6 people. You discuss about mistakes you have done, and you have to end up with a story, a real story with the greatest failure you had. And you need to present this real story with 2 fake stories. It's based on what they say. It's a game. Uh, what the name of the game? It's 2 truths and a lie, and people need to guess what is the true failure you had. Okay. So that is the different activities. They have a conclusion. So I was thinking something that we could implement, for example, for OHBM. That would be great to have this kind of not only in SFN, but OHBM could be also a place where we can discuss about failure. And neuroimaging is also a place where we do a lot of mistakes. They say it's also challenging because for example, for the storytelling, you need to find someone who will agree to present what is the worst, maybe the worst experience he had. So that is something. And second, you need to find someone. It's true that you don't look at the CV saying, yeah, this guy is great. He made a lot of mistakes. So it's not easy to find someone. They ended up with maybe we should find something where we provide award for this kind of also discussion, where you can award someone who has made a lot of mistakes and by doing so is making research progressing. So that was the paper of today, and as I say, I have tweet for you today, and this is I prepare a failure index game for you. So you can flash the QR code or you can go to this. I can copy the link to the chat somewhere. Where's the chat? Here you can click on it if you want. Okay, so I let some people go on it. We'll start when you feel ready. Everybody is on it. So the link is in the chat, or you can flash the QR code. So let's start. Oh, let's go. So you have to press yes or no in 5 seconds. Are the paper rejected? Yes, no. Ah, only one. Okay. Are you ready, people?
You have to press submit as well.
Yes, submit.
Come on, I
Okay.
can't be the only one who had a paper rejected.
No. So we know who you are. Okay, second one. Ready? So you need to press yes or no and submit. By more than 3 journals. Ta-da. Okay. Greater. 4 participants is better. Overslept the morning of an important meeting or important experiment. Oh. Didn't realize that your camera or mic were on at a rather critical moment. Bump the presentation. Oh, yes, 2, all 4. Okay, next one. And it was your qualifying exam or dissertation defense. Great. Oh, 1. Label files as test 1, 5, 2, 3, 4, 5, thinking you will definitively remember what they are. So this one, yes for me. Yeah, a sad one. Lost data due to hardware failure. Can happen. Shit happens. Hurt yourself in the lab. Bicycling, by example. I have an example. And had to go to the hospital. That is really bad. Oh, 1.
We're already there.
What if I was already at the hospital?
Yeah, it's close. At least you are close to it. Set fire to the lab. Let's see. 2. Nobody? Ah. The large experiment turned out to be confounded. Wow. Yeah. Next one. Didn't tell anyone that it was you that ruined the thing. Okay. The manuscripts that sat unfinished for more than 5 years. Ooh, unpublished business here. Next, for more than 10 years. I say, you need to be old for that. Nobody? 10 years, yeah. It's a
That
lot.
was in high school.
Yeah, but yeah. Okay, and why? Next, are the grant rejected? Yeah, yeah. 10 grants rejected. Oh, holy shit. Okay, nobody. To let the students or staff go to do losing a grant support. Yeah. That is sad too. The journal tell you to have a native English speaker review your manuscript and your native language in English. Yeah, we don't know. discovered errors in a paper after it was published. Yeah. Yes, for me too. Add to submit a erratum. Yeah, to retract the paper. Wow, that is a bad one. Okay. Oh, this one. Whoa, 1, 2. Yeah, to ask a question for it. Okay, it's good. I think that was the last question. Yes. So now I'm not. How can I see the? Okay. How can I see the? No, that is already okay. Can I see the? How can I see the answer? Oh shit! I didn't practice enough. Aha! Aha! Yes. I want to see. Ah yes. Here. Okay, the question. Participant 12. Do you have maybe I don't have the winner tonight today.
But we also didn't have to put in our name, right? So that's how would you know?
Yes. For example, but did you put your name in it?
No.
No, there was no question
Didn't
about the
ask.
name.
Ah shit, maybe I didn't put the So we will never know.
Wasn't there a question about this?
Exactly.
It's okay, anonymous.
But
Yeah,
we
there
can
is
evaluate the
utilisator 1.
questions.
User 1 is the winner. So I don't know who is it.
Oh,
11 and 25. Yes, so we are the
But
winner.
we can check the questions, right?
Oh, it's
How
the only
many?
person who actually replied to the first question.
the first one, exactly.
Yeah.
Oh, who was it? Who was it? Yeah, it was Steph. Steph, we have a winner.
Yay.
So in fact, it was designed, this kind of games, this one was designed for the senior researcher to have to have a more probable, to have the higher rate of success, to show that the more advanced you are not completely invisible. You are prompt for error, and so students can see you like a real person. That was the idea also behind this game. So that's it for me. If you have questions, I'm ready for it also.
Fantastic. Thanks. That was great fun. Chris has had his hand up for a while now. So Chris,
Yes.
take it away.
Yeah, I mean, I could talk about that topic for a while, but I find it so it's interesting to discuss failure and stuff, but and it's funny to do games and stuff, but we're not gonna solve anything with that. So I think I mean it's weird that it's still not implemented, and I think I know why. It's because there is money involved at the publication level. We need to well, the journals they don't want failures, they only want the success, so they can have as many clicks as possible, even though it doesn't make any sense for science, because a lot of researchers in a given domain are gonna be doing the same mistakes over and over because they are never published. So this is a problem. Of course, there are some things that are implemented to try to avoid that, like the pre-registration in journals. And I think that's a great idea, but still, it's not very widely implemented. But even that, in the end, is a little bit shy, because you will always try to only write the successes in your pre-registered paper. So, do you have ideas to implement better things?
Yeah,
I do.
it's a. I mean, I don't. Yeah, I don't have answers for that. So I think the pre-registration is one thing. Also to present negative results. It's true that journals don't want money, but it would be if we present more negative results, it will help also the field by publishing this kind of negative results. And I think it's part of the open science progression that we need to be more transparent about our research, how we publish, and I think mistakes, failures are part of it. So we should present them as part of the research and not only hide them. But the system is really constrained to and even us we are biased because once we want to do research we want to have success and but we need to keep in mind and maybe to be aware of it and like any bias we need to start by doing something, so maybe to present to students that we are doing mistakes in the beginning of it and maybe because when a student come and even for the conference, like I say, it's like the Oscar award. They go there, they go only success, great people with a lot of grants and say, oh yeah, I want to do that. But we should tell them it's not the majority of the people will not do that. So we should tell them that, but it will be first
So
difficult.
I got an idea that if I have time and if I'm approved by my supervisor, I put a paper on archive like a year ago, and now I made like so many changes to the paper because I think it was like mistakes, but things that were also not working as well as they could. So what I think I'm gonna do, even though I don't think it's gonna be published anyone, is I will try to write a paper to explain the different steps that I did to improve the paper and where I noticed that things were not working as intended or as something has been published before and I tried the same thing and it didn't work. And I think this kind of work could help also because then you see when someone is trying to use a method, if there is another paper saying, oh, by the way, I tried these other things, it didn't work.
Yeah.
So doesn't mean that maybe I made a mistake in implementing it, I don't know, but at least you have an idea that it might not work. Whereas otherwise you will just waste your time.
Yeah. Yeah, I think it's a great idea. I mean, when we share data, we share the procedures, we share, open data and stuff like that will help because we can be more reproducible and we can maybe reproduce mistakes too and say, this is how we can correct the way, the way to the results.
Anna had her hand up, but she put it down, so I'm guessing her question was answered.
Kind of. So that's There would have it wouldn't add any additional information, but I can come up with a new question.
Okay. Moving on to Lilith then.
We cannot hear you.
Yeah, the continuation of the discussion. So, for example, the paper that showcasing the DeepSeek, another like deep learning AI model like a ChatGPT or something. So, in their paper, they have a section that says like unsuccessful attempts, and they actually describe what they try to do, but they're saying like these methods still can be useful in some cases. So but I really like that end of the paper, they dedicate a whole section that describes failures, and DeepSeek is like actually a great advancement as well. So they managed to publish, I mean, obviously, but like I don't know if this will be a normal practice in usual academic context. but I would really like to see that, at least if you're publishing a successful attempt, just show what you tried already, you know. So
To show the whole procedure, not only the success one.
yeah, and also it will even explain sometimes why you decided to use this method, you know, or
Yeah.
sometimes okay, I tried it. You have this great instinct in science, or you actually tried thousands of other things and this was the only one that worked out. I don't know. Yeah. But
Yeah.
thank you for presenting this paper. It was a really nice one.
Thank you.
I'm just wondering if being open is really going to fix the problem entirely, because we have a lot of code available online, for example, which by definition means that it's open science, but I think someone reviewed it and most the code doesn't actually run if you just put it into your pipeline, basically. And then also, it's not like juniors don't know about the failures, right? They are part of the papers that get rejected. They are involved when we lose our grant funding because they don't get the positions. So it's not like it's a complete secret that we need to uncover. So I guess it's also about not just highlighting that there's always going to be more rejections than successes, but also how to cope with it and how to not get bogged down by it.
Yeah, yeah, you're right. So I think it's part of they talk about resilience, how you can teach resilience about it. So yeah, Matt, I think we should accompany the students to this that they don't happen, because at the beginning you don't write grants when you start research. So at the end you start to write grants, and here I think it's more challenging because papers you work on it, but you know you are doing mistakes. But grants is it's more related to you. So you want money for it. You want to show yourself and to show to other people you can get money and to make great research, and you get completely rejected. It can be very challenging. I think, yeah, it's part of the teaching to them that, yeah, it's part of it. But I think, yeah, we need to cope, like you say, we need to cope with them, to accompany them to these different trails.
Grants feel very personal, right?
Yeah, yeah, it's true that the more, yeah, it's more close to you when you are rejecting on that. So yeah.
Eduardo has a question.
Yeah, I had a question. I kind of forgot it when you spoke about the coding and the sharing issues. Because then I thought that that's also part of a more general problem in the fact that like most of scientists are not like software or engineers, or like there is just so much we can do to make the code as runnable as possible. But say you've written a code in Python 10 years, like 5 or 10 years ago, that's want to be what, like Python 2, that's never gonna work. So that's also part of an issue that is really addressed when people are like super excited. It's like, okay, let's use Python, it's open source, people can use it, but at what cost? Because the consistency of that code is not gonna like last for more than maybe a few years. And also people usually forget about that if you're running like heavy computations, is it open science? I mean, if you cannot replicate it unless you have like availability for like heavy computational power, then it's like you can argue whether it's really open science or not. And the same like for the code. I mean, if you can barely rerun the code, then I would say, is it really open science? So I mean, as of course, like we appreciate the effort, and of course we can always make a few adjustments to the code, but yeah.
Yeah, it can be also a failure.
Yeah, it's also one of the problems. I mean, we do lack replications anyway, and people are not so willing to do them. So
I mean, one way to fix it is because if the code is open and it doesn't work for you, you can always reach out to the team behind the original code, right?
yeah, but then people like not hired anymore. They don't know what the code was doing. I mean, I have to put more comments than code in my own code to remember myself what the code is supposed to do, like say a few weeks later. Otherwise, it's like reading hieroglyphs. And when you open a GitHub repository and it's just plain code with like hundreds of for loops or whatever things you can find there, it's like no one can read this. Like probably not even the authors, unless they are like engineers or like people that do that for like a living. So yeah.
So what's the solution then?
I don't know. I was hoping for some feedback from your side.
Well, I guess if we make the whole system open, right? You make the tools available, you make the teaching available, you make the science available. Things like registered reports tend to work really well, where you put your hypothesis out there, you put your methods out there, and then no matter what the result is, you can publish it. So that also reduces the bias of positive results. So if you do the whole package, I think in the end we're further afield than we currently are. And if you combine that with the storytelling and the games to be aware of where you stand, where the others stand, and how to cope and deal with it, I think then we stand a chance.
Yeah.
Yeah, I mean, yeah, that's definitely true, I guess. Yeah. But yeah, there's this push for like more and more sensational publications, and unless that is taken away, I'm not sure people are willing to be like more moderate in the claims they try to make with the research, because your grants and your financial like your survival is depending on that kind of stuff, and like we all know that, yeah.
But that's short-lived, right? If you have a flashy publication, that's not going to carry an entire career. You need to have solid science
No,
hypothesis.
that's true, but on the short term can give you.
Yeah, we need to be careful not to fancy publications.
Yeah.
So maybe people can say, yeah, I want to do fancy publication, but this is not the way to go, I think.
Yeah, I mean, it doesn't make sense, but we do see like relatively often like publications that are clearly based on an exploratory analysis, and they are presented as if they were like theoretically grounded. I mean, I have nothing against like exploratory analysis as long as you state that that's what it is. And you just don't say, oh, I discovered this and we were predicting this since the beginning, when it's like it's hard. Like if you go through the paper, then it's really a little bit hard to believe sometimes. But yeah, I mean, nice memes in the chat.
Right. We are out of time. So
Yeah.
I'm going to call the discussion closed for now, but thanks for the paper. Thanks for making us figure out our F index. Greatly appreciated that, and that was fun. As always, when you present, it's always something different. That's good. With that, have an exciting week in science, and I see you next Monday. Bye.
Bye.